Okay, ray diagrams. So I'm going to show you 3 different rays that you want to draw on each ray diagram, and then I'll show you after each rule what they look like, what they all look like together, and then we will draw a ray diagram for one of the examples. And it'll be the example that we did in the last video with the lens equation. Rules for drawing ray diagrams. Ray 1 initially travels parallel to the principal axis then refracts to pass through the focal point. Ray 2 does the complete opposite. It first passes through the focal point and then refracts parallel to the principal axis. And ray 3 is the easiest. It travels directly through the center of the lens with no change in direction. Okay, so starting with ray 1, what does this look like? Here's our principal axis. Here's the dotted line I use as a guide, my lens, and then I've got my focal points. And these are equally distant. You should be using a ruler to make sure that they're equally measured from the center of the lens. So this distance should equal this distance. Okay, so ray 1, and this is just a general idea of what it looks like. Initially travels parallel to the principal axis. You're going to get to the center of the lens, and then it's going to refract and pass through the focal point. So that's what ray 1 would look like. Ray 2, I'm doing this without a ruler. It's not working out very well on the iPad. Have our focal point. Ray 2 initially travels through the focal point, gets to the center of the lens, and then goes parallel to the principal axis. This should actually, let me draw this a little bit better. We want to go through the focal point. And then parallel to the principal axis. So that's what ray 2 would look like. And you're not always going to be able to draw ray 2. It depends on where this focal point is located. So this is the ray that might not always be there. And then the last one's the easiest one, ray 3. And it just goes straight through the center of the lens with no change in direction. So ray 3, straight through the center of the lens, like this. When we add them all together, so adding all 3 rays together, gives you a ray diagram. And again, you're not always going to be able to add in ray 2. It depends on where the focal point is and where the object is, but you'll know if you can't draw ray 2. So we start with ray 1, initially traveling parallel to the principal axis, and then it passes through the focal point. Ray 2 is going to travel through the focal point and then go parallel to the principal axis. And ray 3 is going straight through the center of the lens with no change in direction. So where does your image form? Where they cross. If it's below the axis, it's going to be a virtual image and a real image and upside down. The object starts somewhere over here. I didn't show what it looked like. So I'm going to do an example. This is the same example I did with the lens equation to show you what this looks like with real numbers and a real problem. you do want to draw ray diagrams for most of your problems that you're solving with the lens equation. It's a pretty good check in terms of, is the image real, is it virtual, is it right side up, is it upside down? So the ray diagram you should draw to scale, and it should be a really good check to see if your numbers are agreeing with what you draw. Okay, so the reason these are all written on graph paper is because you want to be able to scale everything. So let's get right to it. We have, you've already seen the problem. So you have a 2.25 centimeter tall object is 8.5 centimeters to the left of a convex lens. So let's draw this out, and I did tell you to leave room. We need our principal axis. Oops. Did not mean to do that. Okay, so the principal axis. Rulers do not work well on the iPad. I'm just going to freehand this. And then I need my dotted line and the lens. Doesn't matter how thick or thin you make the lens. Tells us the focal length is 5.5 centimeters, so you actually want to measure that out. We're going 5.5 centimeters from the edge of the lens. I'm sorry, from the center of the lens. So this would be my focal point, and then 5.5 centimeters from the other side as well. So it would be right there. The object is 2.25 centimeters tall, and it's 8.5 centimeters to the left of the lens. So my object is located right here, and it's 2.25 centimeters tall. So it's about that tall, extending my principal axis. Okay, so now we want to draw in the ray diagram. We need to draw our three rays. Ray 1 initially travels parallel to the principal axis and then refracts through the focal point. And again, I can't emphasize enough, you should be using a ruler. Ray 2 travels through the focal point and then parallel to the principal axis. And ray 3 goes right through the center of the lens with no change in direction. If I drew this nicely with a ruler, we would see all three of them were converging around here. So it's below the principal axis, which means that it's upside down. So we know that the image is real. And then you can measure it. Yours should be much more to scale than mine was. So once you measure the length of this, that would tell you your image height, which is one of the things you're looking for. And then the last thing you would look for would be the length from the center of the lens to this, where the image is located, and that would be your image height. I'm sorry, your image distance. So when you do this with a ruler and actually measure things out a lot more carefully, the ray diagram is a really, really good check to see if your numbers are working out. So again, use a ruler, make sure you're measuring, be a lot more careful. I just had ruler issues. And make sure you're drawing at least ray 1 and ray 3. You won't always be able to get ray 2 in there. So that's how we draw a ray diagram. The last thing I want to look at are the 6 cases for converging lenses. We'll do plenty of practice with drawing the ray diagrams for all the problems with the lens equation. So we'll look at the 6 cases for converging lenses. I'll talk about that in class just so we can actually see this done with a ruler. I'll do it on the DocuCam so we can get a nice clear picture of what those look like. So that's ray diagrams. If you have questions, we'll talk about it in class. Otherwise, between ray diagrams and the lens equation, that was the last thing to learn for optics.